Hello everyone, this is Wang Zhe from Smart PV Business of HUAWEI Digital Power. Now I'm in Wenchang City, Hainan province of China. The 25 megawatts, 50 megawatt hour battery energy storage system that behind me is not only the benchmark project of Datang Hainan Energy Development Company, but also the largest PV and ESS project in Hainan province so far. Now please follow me to have a closer look. The project adopts the HUAWEI Smart String ESS brought 4 major benefits for our customer: higher revenue, optimal investment, simple O&M, and more safety through a series of innovative features, including pack and rack level optimization, distributed cooling, 4-level active protection, etc. This project is also seen as a milestone of Hainan Clean Energy Island strategy, which aims at expediting the carbon peaking and carbon neutrality goal achievement. Next, please follow me to have a closer look of the project. HUAWEI Smart String ESS uses a 20-feet container with a large capacity LFP battery cells. The nominal energy capacity of each ESS container is about 2 megawatt-hour supporting scenario over 1C or less. In addition, HUAWEI Smart String ESS supports fully assembled transportation, which only need a simple external cable collection on site. And together with one-click commissioning, the construction period can be shortened significantly. That's why this project takes only about 1 month for construction, from hoisting, wiring to grid collection, which is amazing speed for large-scale ESS project. The fast delivery helps customers to generate yields immediately by providing services like peak shaving, frequency regulation for the power system. HUAWEI Smart String ESS adopts isolation design, consists of 3 cabins: the battery cabin, the smart rack controller cabin, and the control unit cabin. First, let's look at the battery cabin. The battery cabin is composed of 6 symmetrical battery racks, which is composed of 21 battery packs in series. In the traditional solution, batteries are directly collected in series. When one battery is fully charged or discharged, the other battery packs will stop charging and discharging, which will cause a waste of available capacity, according to the so-called kinetic law. In order to solve the problem, we integrated an optimizer in each battery pack. When that battery pack is fully charged and discharged, the optimizer inside will bypass this battery pack, which can allow other battery packs continue to charge or discharge to full level. That is pack level optimization. This is the battery pack. On the front side from left to right is the BMU, cooling fan and optimizer. And in the middle and the rear side are cells part. Each pack consists of multiple LFP battery cells collected in series. Each battery cell has a voltage sampling point, and multiple NTC temperature sensors are embedded in the pack, which can monitor the status of each battery cell in real time to ensure they are working in the best condition and reduce the risk of thermal runaway. To reduce the impact of high temperature on the service life and available capacity, HUAWEI Smart String ESS adopts a distributed temperature control and independent heat dissipation design, which can significantly reduce the temperature difference within the system. This is the distributed air conditioner. On the top is the air exhaust vent, where cold air comes from. HUAWEI adopts the patented bionic air duct design, which ensures the temperature balance of each battery cell, allowing the energy storage system to achieve higher available capacity and a longer service life. In order to monitor the status of the ESS in real time, 4 temperature and humidity sensors, 2 smoke detectors, 2 heat detectors, 6 carbon monoxide sensors, and 1 water sensor are installed in the ESS. Next, let's look at the smart rack controller cabin. In the traditional solution, the battery racks are directly collected in parallel, which cannot avoid the inter-rack circulating current and SOC inconsistency, resulting in low available capacity of the ESS. HUAWEI Smart String ESS adopts smart rack controller to realize the independent charging and discharging of each battery rack, eventually to achieve higher available capacity of the whole ESS, that is, rack level optimization. Combined with the pack level optimization just mentioned, the discharge capacity during whole life cycle could increase over 50% compared with traditional solution. Safety is always the top priority for battery energy storage system. HUAWEI Smart String ESS adopts 4-level active shutdown and 2-level physical isolation to implement comprehensive overcurrent protection from battery packs to system and from software to hardware. For example, when there is an overcurrent fault occurred, the system triggers the BMS to limit the current of the battery packs and racks from the software side. If the fault is escalated, the battery pack and the smart rack controller will shut down the system from the hardware side. Furthermore, each battery rack is equipped with circuit breakers and fuses to isolate faults and ensure safety. In addition, when the ESS is not running, for example during transportation or installation, the output voltage of a battery pack is 0 volt, which can protect the construction and O&M personnel from electric shock accidents. Finally, let's take a look at the brain of the ESS, the control unit cabin, which consists of the main control system, fire suppression system, and power supply and power distribution system. As those systems are located in separate cabins from batteries, the normal operation can be guaranteed, even in extreme situations, to protect the safety of the whole ESS. To ensure reliable operation of systems in control unit cabin, a temperature and humidity sensor and the water sensor are installed in it. On the left side is the air conditioner for heat dissipation of control unit cabin. This is the DC wiring terminal and DC circuit breaker. In the middle are the rectifier unit, monitoring unit, and the CMU. HUAWEI BMS adopts a 3-level architecture, including pack-level BMU, rack-level BCU, and system-level CMU. The BMU and BCU are embedded in the battery pack and the smart rack controller respectively. On the right side is a fire cylinder with clean fire extinguisher as an immersion fire suppression in extreme conditions to ensure the system won't reburn for a period of time and avoids accidents expansion. And here is the extinguishing control panel to implement the alarm and the automatic fire extinguishing control. This is a brief introduction of HUAWEI Smart String ESS. HUAWEI provides us a complete set of solutions. Besides the ESS container just introduced, it also includes DC low voltage panel and smart PCS. Now let's have a look. This is DC low voltage panel. This is PCS. The HUAWEI PCS adopts a string and modular design. The power of each PCS is 200 kilowatts, and the protection degree is up to IP66. If a single PCS fails, it only affects 200 kilowatts output, which means the impact of the system is very limited. Meanwhile, the PCS adopts smart grid collection algorithm, can realize stable grid collection with SCR greater than or equal to 1 and 1. Besides, the performance of fault right-through, high and low voltage right-through, and IT island protection is excellent, which can realize adaptation to the grid of almost all scenarios. Thanks for visiting HUAWEI Smart String ESS showcase with me. By integrating multiple technologies, including power electronics, electrochemical, thermal management, and digital technologies, HUAWEI Smart String ESS is always committed to provide solutions with higher energy capacity and more safety. In the road of carbon neutrality, HUAWEI will work closely with global customers and partners to drive the energy revolution through innovation to build a green and bright future.